All right, so now let's try with numbers. So it says the same setup is done before. So Thomson had electrons accelerate straight through. Both electric fields are turned on. Then they turn it off and allow it to rotate in a circle. So step one, I'm going to say the magnetic force is equal to the electrostatic force. In other words, QVB is equal to EQ. I can simplify the charge by canceling it off. And now we're left with velocity, magnetic field, and electric field. I do know the speed, but I don't know the magnetic field, and I don't know the electric field. So let's jump over to the second setup. In this case, we're saying that the magnetic force is causing it to move in a circle. So therefore, charge, velocity, magnetic field is equal to mass, velocity squared over radius. And in this case here, I know everything because it's mentioning that it is an electron. So I know the charge, I know the mass. So one thing I don't know is the magnetic field strength, which would be mv over qr. So the mass, 9.11 times 10 to the negative 31 kilograms. The speed, 3.5 times 10 to the 6 meters per second. The charge, 1.6 times 10 to the negative 19 coulombs. And the radius, 4 centimeters, 0.04 meters. All right, let me pull up my calculator. And I end up getting 4.98 times 10 to the negative 4 Teslas. All right, so now going back to the first step, if I want to solve for the electric field, well, electric field is just a velocity times the magnetic field. So I'm going to take that same velocity of 3.50 times 10 to the 6, and then multiply it by my answer that I just got, 4.98 times 10 to the negative 4. And I get electric field of being equal to 1.74 kilonewtons per coulomb.